Hi, Databricks community. In the previous session regarding the Databricks Data Engineer Associate exam, I had given insight into what is big data, what is Hadoop, and what is Hive. While talking about Hive, I told Hive gives us interface onto the data sitting in Hadoop distributed file system. So Hadoop has vast amount of the data with it, which is distributed across the cluster, right? Group of nodes are there, part of the data in one machine, part of the other data in the other machine. Okay. On top of it, we are deploying the Hive so that we can query the data present in this Hive distributed, uh, Hadoop distributed file system by writing Hive query language. So that is SQL-like language. So that was uh, one of the important, uh, update at that time, so that the developers do not really rely upon Java programming for processing the data present in Hadoop distributed file system. As I was mentioning, as you create tables out of the data present in your file, to track the tables and databases we are creating in Hive, we need Hive Metastore. That's what I'm trying to indicate here. Hive Metastore, it will be holding all of the metadata, which will be referencing the actual file content, maybe from Hadoop, maybe from Amazon S3. So these are what we have got, okay, from the cloud and all. Against this data sitting over these, object stores, we have the tables created in Hive. So information about the tables that we have created, referencing the data from these different data sources, is present with the Hive Metastore. In the backend, this Hive Metastore is nothing but kind of relational database. Okay, it can be MySQL, it can be PostgreSQL. So it will be continuously keeping track of what tables, what partitions, right? Databases we are creating in the Hive. And this is important for us, as you see here. Not only Hive will be relying upon this Hive Metastore to track its tables and all. Even Spark comes here. Okay, while we are preparing for Databricks Data Engineer Associate, uh, we should be knowing the Spark first, because Databricks is nothing but the platform that is built on top of the Spark. So here you could see you can actually work with Spark with the data that is present in Hadoop, right? And just like how Hive is creating tables for the data present in Hadoop, even Spark does that. Okay, Spark also tries to create tables against the data present in Hadoop, or something else, right? It can process the data present in Hadoop, and if at all Spark is choosing way of writing structured query language against the data present in Hadoop, or for that matter anywhere else, it also requires Hive Metastore, okay, kind of the service to hold the metadata related to the tables and all. Right? So that point you have to remember here. So with this background, let us now move on to discuss about Spark. Right. So what we have so far looked at is Hadoop. One second. Okay, we have looked at Hadoop, and then we have spoken about okay, big data and all. Let us switch to maybe this one, right? Hadoop, and from there Hive, and from there, okay, we are now moving to talk about Spark. Spark, just like how all of these are open source, Hadoop and Hive, Spark is also open source, right? Its code base is available to the public. If you want, you can, okay, contribute yourself onto development of Spark as well, and you can modify it. Fine. So open source, it is written in Java and Scala. Okay, it doesn't mean that you have to work with Spark using only Java and Scala. And it has overcome the challenges of Hadoop and Hive. Hadoop was slow, but Spark is fast. How much Spark? It is 10 times fast in memory. Okay, and it is going to be excuse. This is going to be 100 times fast in memory and 10 times fast over the disk compared to Hadoop, right? To give the definition of Spark, it is in memory, okay, distributed data processing engine. So it is purely into data processing. It doesn't itself bother much about, providing the storage, right? So it is data processing engine. So whenever you want to process the data, you have to identify the data sources where the data is there. From there, you have to pull the data and put it into your, Spark environment, process it. Once the processing is done, again, that processed data you take to wherever you need it, right? So it is meant only for data processing purpose. Fine. And Spark is fast. It is in-memory data processing engine. That's why it is faster than Hadoop. And you don't have dependency on Java. You can program with it using Scala, using Python, using SQL, using R language. So like that, we have good enough of options to work with Spark. And not only that, uh, Spark gives us way to work with batch data as well as streaming data. Hadoop was good at processing only the batch data, the data that is already accumulated. Maybe 10, 100 gigabytes of the data is there and you go about processing it. But Spark is good at processing both batch data as well as the data that may arrive in real time, right? So Spark is good at both of them. So what are the components of the Spark here? Spark uh, framework is made up of Spark core component, Spark SQL component, streaming component, machine learning library related component, and graph database processing component. Okay, graph data processing component. But as a data engineer, our focus will be on to Spark SQL and streaming stuff. But Spark core, which is the low level component in the Spark framework, it is good to have basic understanding of the things from the low level so that it is easier for us to understand going forward Spark related stuff. Right. So I will be covering initially, if not in depth, uh, somewhat, as much essential, that much of information for the Spark core. Then I will be covering the Spark SQL streaming part. So these are out of our focus. So we are going to rule them out. Right. So now here to work with the Spark SQL, what you need. Okay. Uh, Let me tell. So for that, first let us talk about what you will be working with at the Spark core. So when you work at the Spark core level, you will be creating something called RDDs and you are going to work with them. So just like when you're working with Python, you get to create variables, and that variable may point to a single integer, a string, or it may point to a list, right? It may point to a dictionary, so like that. So while processing data in your Spark, you hold the data in RDD. Just like how Python list can hold list of elements, your RDD will be holding the data set that you want to process, fine? So it is the RDD that you are going to work with. But otherwise, if at all you are choosing to work at higher abstraction level, so it is a data frame you will be creating and you will be working with them. And while working with the streaming also, the abstraction that you will be using data frame itself, fine? But then see, you can just maybe start going on to Spark environment and you can try creating the RDD's data frames. But let us take this journey, okay, uh, step by step, gradually without missing any kind of basics. So very basic fact that you have to know before you start working with these stuff is Spark architecture. Yeah, you should be understanding the Spark architecture. So how are the Spark clusters deployed? What they are made up of? As I told, it is in-memory data processing engine. So Spark is going to rely upon the distributed architecture. That's the cluster. So how does the Spark cluster look like? So let us try to understand it. For that, Let me take help here to draw some simple diagram. Okay, 1 second. So let us okay, think that this is one machine in the cluster, and then we have group of other machines there. This is one more. Let us think of four of them are there for us here. And to make this a cluster, there should be connections between the nodes, right? And this one is the master or the driver, okay? And these are the worker nodes, fine. So now when the user have the Spark program, okay, you will be having the Spark program. This Spark program, to get it executed on the cluster, you will be submitting it to the master. Okay, master is the machine over which a Java process, okay, which is a Spark process, right? Spark is written in Java, so internally whatever Spark related processes are there, so they will be Java processes. So on this machine, which we are calling as a master here, a daemon or the process called master will be running. Okay, name of the Java process is master. So when the user submitting the Spark program to this master, so over this machine, okay, master is going to take a look at the program that you have submitted, and in your program you would have written one entry point into Spark execution, just like in case you are aware of Java and all. So there is going to be main method which is going to act as entry point into the execution of the program. So just like how the organizations will be having the entry gate. So once you get into the entry gate, then only you will have access to other provisions of the premises, right? So similar way. So there is going to be entry point. So so that kind of entry point related code gets executed here, and that is called as Spark context. It is called as Spark context. So for each of the Spark program submitted by the user to the master, you can call this to be simply program, or we can call this to be application. So for every application, there is going to be only one Spark context object. And this Spark context object, which is the entry point, is going to keep track of overall progress of your application, as well as it is going to act as bridge between your application and the cluster, the whole of the worker nodes and this master and all, right? So that way it's very important. So whenever you are writing the Spark code, the first thing that you do is you will be creating, okay, Spark context object, Spark context object, fine. So that runs here. So now uh, this guy, right? The Spark context is spinned up here, and it is asking for the program to get executed. Okay. So now master, right? Master is going to tell about the resources that are available over the cluster so that program gets executed. So Spark context itself, right, actually doesn't know about whether resources are there or not on this cluster to get the program executed. So you will be asking the master, hey master, tell me whether I have the resources or not so that I can execute this program. So this master also, actually, he himself doesn't know, right? He himself doesn't know on his phone. You will be relying on one more, okay, member in the cluster who is called as resource manager. Okay, so it will be deployed along with your Spark cluster. So this master speaks to the resource manager, okay, to know about whether actually resources are there or not over the cluster to execute the program. So what's the meaning of resources are there or not over the cluster to execute the program? We mean whether the systems are free or not, the CPU cycles, the required memory and all is available or not, so that this program can be executed, right? So this resource manager always he will be having, okay, entries related to, okay, what machine has how much of resource availability at a given point of time. So when Spark context wants to execute the program. It is going to ask the master to tell about the resources. Then master is going to check with the resource manager and will give map of resource availability over the cluster. And accordingly, this Spark context is going to split your application that you would have submitted, right, to the master into jobs. The application is split into jobs, and these jobs are split into stages, and these stages are split into, okay, tasks. These stages are split into tasks. So this is how the application is broken down to get the data processing done by the Spark. This is the case. So the smallest execution unit in the Spark, okay, execution model is task. Here, your Spark context, after getting the information about the resource availability, it is going to break down into these tasks, and tasks are assigned to the workers, okay, to do the job. Fine. So in these worker machines, who is actually going to, okay, work upon the task? In the worker machines, which are nothing but, I can say, the physical servers here, in each of the worker, we will be again spinning up few more Java processors, which will be actually processing our data. And those Java processors are called as executors. So in each executor, we are going to spin up, in each worker, we are going to spin up the executor. So as the name says, these executors, which are nothing but Java processors, they are responsible for executing your tasks. Right? So in the next session, I am going to talk about how to decide how many number of jobs to be created, how many number of stages to be created, how many number of tasks to be created, and how do you actually know about how to spin up these executors? How many executors can be spinned up over each of the machine? And what resources you are going to allocate to each of the executor? So all these are very, very important from your, okay, Spark skill perspective and your interviews perspective also. All these will be discussed in the upcoming, okay, session. Thank, thank you.